Hi, I want to make a quick video showing some of the history of John Deere Starfire. This is all like really deeply connected with Navcom, the actual Starfire correction system, and then of course the green star displays in the tractors. Like Starfire, like as far as like the hardware goes, is like very poorly documented as far as when stuff was made. So I'm just gonna go through like a brief summary. This is kind of more just a research video, and like 90% of this, probably 80 or 90% of this is correct. There's errors in this, and I'm kind of making this in response to there was a very good podcast episode done by like a John Deere dealer going through most of this stuff, and they got a lot of it right. So this is kind of just like a kind of supplemental add-on part of my own research. So early on, Navcom had this dev kit basically here that they had in like the mid 90s. I couldn't find an exact release date when it was first available. There's some documentation that data sheets that have this dated back to available in like 99 to early 2000s, and this module here was used in many of like John Deere's early Starfire receivers. So this was L1, L2, and it had 12 tracking channels, had 10 satellite tracking channels, and 2 WASP channels. It was GPS only, and it supported the NCT protocol and RTCMN for base station corrections. And it had it also supported what was essentially SF1. Um, I think the later versions did. So the later NCT 2000s did internally in the module would actually demodulate the L band correction signal, which is on a frequency close to the GPS bands, and internally use that correction information. And this is a wide area differential correction service is how the original Starfire worked. So this is it, and if you look at the antenna, it's basically the same antenna. And here's an old website I found that had this is the old Navcom website that actually detailed their early explanation of Starfire. The early Gen 1 Starfire, that's what I'm going to call it. It was just named Starfire, I think, from John Deere. This is the antenna assembly. I'm not totally sure if this just has like the LNA, which is a low noise amplifier, or if it actually has the module itself in here. And this is the actual receiver itself. It is notable that these had a C-band demodulator chip in them. And this is because at this point, Starfire was not broadcasted on L-band. So and that's probably what this thin shaped lip is on this antenna, is like a flat, almost like a thin PCB antenna. Not a PCB, like it's obviously not that, but it's like the copper's in that flat bit for the C-band. I don't know. This is speculation, but Navcom actually developed a ASIC just for this one module, and they never used it again once they were able to push corrections over L-band. Yeah, kind of interesting. So the Gen 2 Starfires used this exact same antenna. They used that same 12. They used that same 12 channel receiver. They dropped the C-band, and there is no real hardware difference in the Gen 2 Starfires that's notable, except there is some reason that John Deere had everyone trade in the Gen 1s to the Gen 2s, and nobody kept the Gen 1s because, I mean, if you didn't do the trade-in, you were going to lose Starfire corrections, and this thing was basically a paperweight. I mean, you could use it with WASP, but almost nobody kept the Gen 1s. So the Gen 2, has the yellow top. It supported SF1 and what I'm going to call SF2 Legacy. So the SF2 on this model and the ITC, which we're going to get into, John Deere posted as a 10 centimeter pass-to-pass differential accuracy. And typically when John Deere documents this, they document it. This is 2 sigma error. So that's 95% of your passes are going to be within 10 centimeters. And this is different than the later version of SF2 that was on other receivers, which I think there was substantial differences. And early on, like in some public documentation, they referenced that Starfire used the early RTCM spec for actually pushing their corrections from the Starfire network, like their wide area correction service. It was, I think, RTCM 104 differential correction message. I think this is what Starfire, the early Starfire used, which would be Starfire 1, the original SF1, and the SF2 original / legacy. And this all ties into why your ITC in 2021 is no longer supported. There were substantial differences between the two. So in 2002 is when John Deere came out with AutoTrack. And AutoTrack always required, like when it first came out in 2002, you would run this with the mobile processor, the brown box. That was the only thing it was offered on, because you didn't have the Gen 2 or the Gen 3 Green Star. And it would it required what they called the TCM, the Train Compensation Module. And on the Gen 2 Starfires, this is external. Another thing is these had a different pinout. They did not have the radar output. They might have been pre-CAN bus. They were just serial. I'm not totally sure on that. But yeah, you would plug that into the TCM, and then the TCM would go to the brown box, and that would the early TCMs provided yaw and roll angle. They were not 3-axis. I think maybe they were a 2-axis, maybe they were a 3-axis accelerometer, 2-axis gyro. We're not totally sure. But yeah, that's the Gen 2. The Gen 3 used that same 12-channel module. The only difference in the Gen 3 really was that they moved to they had the integrated TCM. There were some payment options that, like, where there was free SF1 with the Gen 3, paid SF2, and what are the other differences? So they moved to like a hermetically sealed enclosure with the ITC. The hardware was like the actual, like, physical. I have some teardown pictures. This is of, I think, a 3000. This is a 3000 here, but they moved to this. It's a single sealed, like, this is plastic welded, so it's just a single. It's 2 PCBs, PCB for the antenna, a PCB for all the electronics, and yeah, a substantial hardware difference from this, but it still used that same 12-channel GPS only, based around the NCT 2000, as far as the GPS receiver was concerned with the ITC, and it was L1, L2 GPS only, no GLONASS yet. But this did introduce that standard 12-pin pinout that we have, all the way from the ITC all the way up to our modern John Deere receivers. And then you move on to the 3000, or I have this in here. There was this Starfire 300, and I would not even classify this in John Deere's like lineup really, because it wasn't built on the Navcom stack. It was SBAS only. It used some commodity GPS module, probably U-blocks. Nobody's tore one of these down to confirm. It'd be an interesting find. There's like one on eBay for pretty cheap. If anybody wants a teardown, I'm here. And these were sold with like a low-cost light bar. They were, very few people bought these. They were pretty garbage. They were really only good for like really basic GPS. And there in 2008 there were plenty of light bars, so it was kind of weird Deere even built this. The next real generation after the ITC was the Starfire 3000. Came out in 2010. This internally used the SF3050. This was their L1, L2, L5, 55 channel module. It used the same core. The actual hardware design, though, was very similar. Used the same hermetically sealed dome with the 12-pin connector at the bottom. But this did give you it was GPS plus GLONASS, and this was the one that introduced the real SF2 or the current version of SF2. So they had a different correction stream. They had a different transmission, like the actual, I think the L-band frequency might be different, at least the protocol. And then probably the protocol is different with this version of SF2. And this is the version of SF2 where they claim 5 centimeter pass to pass. Another interesting thing is you could run RTK with these, and on the old software you would get 15 minutes of coast. And the coast is just basically predicting, what those corrections would have been, is the high level way. This is not. And then Deere also has this RTKX, which is where it just reverts. In the case of the 3000, it goes back to SF2, and this is after you run your 15 minutes out, you'll drop back to SF2, which is at that point it's not using any base station data anymore. It's purely relying on the satellite corrections. And this is on this is 20-2 and later they added this feature to the 3000. And originally you only had the 14-day fallback to RTKX on the 6000, but you do have this on the 3000, but it is SF2. The next software the next dome they had was, most people are probably pretty familiar with this one, was the Starfire 6000. This used the SF5050 internally. Came out in 2016. It was L1, L2, L5. I think it probably had, maybe they did. The SF5050 is capable of doing Baidu and Galileo. I don't know for sure if they actually use that. Again, this one also does the coast is with SF3 versus SF2. And then the Starfire L3 or the Starfire 7000, we know for sure that one uses all 4 constellations, and this is the first receiver which has SFRTK. So SFRTK, this is also a big question. Is SF3 like a SSR type correction service where they're actually like resolving the integer ambiguity like you do with like a base station RTK with double differencing? I'm not sure if it's SFRTK or SF3 that can do this. There's a chance SF3 and SFRTK are linked tech stacks, like as far as like how they work. I'm not totally sure on that. That's an interesting question. And then the Starfire 7500, this is just a basic hardware like revision. They're basically the same. So yeah, that is the whole lineup. I probably could do some more digging. I got some stuff on the displays, but yeah, this is just a basic research video. Maybe somebody can find some interesting info. I'll link this like really crappy sheet in the description. Yeah, John Deere stuff's pretty interesting.